This week's lesson is all about simple machines and mechanisms, and in the end how they relate to clean energy. So kids are going to learn about things like levers and pulleys and mechanical advantage. They're going to learn about how a turbine generates energy, and they're going to learn using simple maths how a crane operates safely, and they have a couple activities related to first the law of the lever and second to building a turbine. After learning about different mechanisms, the kids are going to move on to the law of the lever. And the first example we use is a crane. So ideally, if you have access to a whiteboard, you'll have a marker and you're going to run through some quick maths as you do it. So that might be as simple as drawing a crane, drawing a boom and the back end, and then saying, for example, if the back end weighs 10 tons and is 1 meter away from the center point of your crane, what's the heaviest item I can lift on the boom? And using simple maths, you might say if the boom is 5 meters long, it's 2 tons. And so that's 5 multiplied by 2 is equal to 1 multiplied by 10. And the kids will have a basic understanding of the law of the lever and how a crane works. That will then lead you nicely on to the activity, which is using the materials here. So we have rulers, blue tack, and several marbles. Now, this is done at the edge of a table. Try and avoid that. After I find roughly where my ruler balances, I'll just check out that the maths there. Try and use as little blue tack as possible, or else it will throw off the results a small bit. So I'm going to take 1, and the middle is 15.5, so I go back 5 is 10.5. And that way I should be able to put another marble the same distance off the other edge, and things should still balance. Now, this is where it gets a little more complicated. So if I wanted to place 1 marble at 28 centimeters, which is 13 from here, to balance that out, I will need 13 the other side. But 13 the other side is the same as 2 times 6.5. So that should be, if I get my maths right, there we go. So we're going to use different combinations like this. Try and get as many different groups as you can to do different combinations, and check the maths beforehand. So it's really useful if before the kids actually start putting marbles onto the ruler, if they first work out the maths. So for example, if they find the midpoint is 15 centimeters and they want to put 2 at the 27 centimeter mark, they're going to take the distance, which is 12 centimeters multiplied by 2, so 24. So they have 24 on this side. They're going to want to have 24 at this side, and they can make that up in any way they want. So if, for example, they wanted to put 4 marbles there, they could put 4 marbles at 6 centimeters from the center. So that would be at 9. Each team has more or less as many marbles as they want, but for the sake of keeping the maths simple, I would maybe encourage, say, 1 and 1, then 2 and 1, and go from there. Hopefully they have a few minutes of fun just at the edge of their desk trying to get things balanced. And the idea is that we can kind of trust maths. Once we get the figures going and we know the law of the lever, we can build any kind of configuration we want, and it should work out. This part of the lesson then is about how we generate clean power through turbines. And so when we think of renewable energy like hydroelectricity or wind energy, generally what it is we're taking the movement of a fluid like air or water, and we're using it to spin something, and by spinning it we can generate electricity. What we have is a lesson here. So we're going to build a really simple turbine, after which the more advanced kids in the class might give a go at building a wind turbine. We have plastic cones, we have skewers, spools and foam. The idea is to build a turbine that will take the movement of air, so blowing on it and convert that into rotational movement. And as we know, rotational movement can be converted into electricity. So pop this open. Now, moment of truth. So we'll ask the kids to take their time doing this, and there are a couple of things that are really important for it to work. So we explain the concept of friction. If there's anything in the way of our stick rotating freely here, it will slow it down and really kind of stop any progress. So you want to make sure that there's nothing in the way here. Another second thing is to make sure that all of our wind catchers are facing the same direction. So we want the scoop ideally to be where we blow against, so it catches the most wind. This should be somewhat intuitive for the kids. So ask them to think about how it will move. So the scoop is on the inside at all times. And other things to note then is try and use roughly the same weight of foam. If one is significantly heavier than the other, it will fall to the bottom and it'll be really hard to get it rotating. So again, to go back to our principles of symmetry and resource efficiency, try to have it as light as possible, try to have no friction on the spool, and try to have all of your scoops in the same direction, and then hopefully it should run pretty well. So some of the kids might finish that quite quickly, and we have a second kind of iteration for people who maybe finish a bit quickly. So this is to try and emulate an actual wind turbine. So the difference between the wheel that we built and an actual wind turbine is, in a wind turbine, the direction of the fluid movement, so the air, is actually different from the movement of the wind turbine. So we have, for example, in a wind turbine, the air blows against it and the blades spin in a different direction. Whereas in a water wheel, the water would come this way and rotate it around. So we're trying to get kids like, how does that work? And the trick to a wind turbine is the feathered blades. So the blades, rather than being straight on, are at a slight angle. And so that means when the air hits them, it pushes them down, and the next blade comes along, pushes it around. And so we want to have three blades. You'll see them on all wind turbines because it's the best balance between cost and efficiency. So next is to try and make a wind turbine. And so that would mean that the direction of the airflow is actually different from the way it spins. First thing you want to do is set up your tower, and then we're going to want to try and make our blades. So one thing to do is to make your blades a small bit thinner. So the guys from our water wheel looked a small bit like this. If we can cut some off, they begin to look a little bit more like the flat blades we're familiar with on a wind turbine. And now the tricky part is to get those guys set onto our shaft. One spool here, you can lock that in place with some blue tack. That should stop it from just bumping back. And now our counterweight. Now, and that means, really simply, rather than the water flowing this way, we're having wind blowing this way and producing rotation. And the advantage of this is that the tower can then follow the wind in whatever direction, whereas a turbine will only run if the liquid or fluid is moving perpendicular. So ask the kids about how this might work. I don't expect them all to get it finished in one day, but the important things here are to make your blades a bit thinner, to put them on in a feathered position. So what that means, if you wanted to demonstrate with a sheet of paper, for example, is that if the wind is coming this way and it's flat, it's just going to push it straight back. If you put it at an angle and the wind comes this way, the wind is going to push up and then cause the paper to move down. The next blade comes into its place, wind comes along, pushes up, the blade goes back, and you have rotation. So if it's held flat, it just pushes back, as in our water wheel, and if it's at an angle, it can cause a rotation. At the end of this lesson, then kids should know that mechanical engineers take the principles of engineering and apply them to simple problems. It gives you machines like cranes, like turbines. Turbines then are the way we generate clean power using things like water and air, and even so far as tidal turbines. So anytime you have a moving fluid, you have a turbine generating electricity. Kids know about simple machines, and as always, they can look at the slides for next week's question.